Hello everyone. Today let us discuss the topic called losses of prestress. So this is the second module as per your syllabus. In this module you will be having losses of prestress and deflection of the prestressed members. So losses of prestress. In this topic we are going to study what are the different losses of pre-stressing force occurred in the pre-stressing members. In previous module, while solving the problems, we have considered certain loss percentage like loss ratio of 0.8 or loss of pre-stress as 15% like that. So on what basis they have decided the percentage of losses, that we need to learn or we need to understand. So in this module you are going to study what are the different losses of pre-stress we can see in the pre-stressing members. So usually in pre-stress losses will be classified into two groups. One is immediate losses and another one is time dependent losses. In immediate losses means the losses which we find while casting, while applying the pre-stressing force and before the transfer of the member to the structure, that is at the stage of transfer of pre-stressing force on the concrete. And time dependent losses, as the name itself indicates, it takes more time, that is gradually reduction in the pre-stressing force. So these are the two different groups we are classifying the pre-stress losses in pre-stressing force. So here we have three different losses in immediate losses and three different losses in time dependent losses. In immediate losses we have loss due to elastic shortening, loss due to friction and loss due to anchorage slip. And in time dependent loss due to creep, shrinkage and relaxation of stress in steel. Also we need to remember which losses will occur in which condition. That is very important what you are seeing in the table right now. So we have two different conditions or two different types of pre-stressing. One is pre-tensioning and post-tensioning. Pre-tensioning is nothing but applying the pre-stressing force for the tendon before casting the concrete and then we are going to cast the concrete. But in case of post-tension, first we are going to cast the concrete by providing an duct for the provision of tendons and later we are going to apply the pre-stressing force. So first in pre-tensioning we are having four different losses. One is elastic shortening of concrete, shrinkage of concrete, creep of concrete, relaxation of stress in steel. If you come to post tension, here first one is elastic shortening of concrete, there is a condition. Then shrinkage of concrete, creep of concrete, relaxation of stress in steel. Along with these four we are having two additional losses, that is friction and anchorage slip. So first let us consider pre-tensioning. So pre-tensioning means before casting the concrete we are applying the stress. In elastic shortening, loss due to elastic shortening of concrete. So if we are applying the stress for the tendon, then we are going to cast the concrete. The stresses, the amount of stress, tensile stresses developed in the tendons will be same as the amount of compressive stress developed on the concrete by means of the tendon. So in that case, in between some improper bonding will be there. So because of that there will be slight loss of stress in the tendon, that is elastic shortening of concrete. Shrinkage of concrete means the shrinkage, as name itself indicates, it is shrinkage, that is reduction of the volume. So when the volume reduces, obviously the stress in steel reduces. Then creep, permanent deformation of the concretes. So for a longer time, if you stretch the elastic for longer time, the elastic loses its elasticity. The same thing will happen in steel also. So elasticity, if it loses its elasticity, it will loses the strength. Next, relaxation of stress in steel. That's what. Then post tensioning. Here for elastic shortening of concrete, we have condition. If you have providing only one tendon, there will be no elastic shortening of concrete. There is no elastic shortening of concrete at all when we have provided only one tendon. Then if we are providing more than two or more, like 3 tendons, 5 tendons, depend on the requirement. So in that case, it is very important, you should remember that in post tensioning, elastic shortening of concrete will occur when you have applied the tensile stresses for the tendons one after the another. That means first you are going to stretch one tendon, then you are going to anchor that, again you are going to stretch another tendon, you are going to anchor that, again you are going to stretch another tendon, and you are going to anchor that. In this condition, there will be loss of prestress due to elastic shortening. But if you apply the tensile stresses for all the tendons what you have provided, for example you have 5 tendons, if you apply the tensile stress for all the 5 tendons at a time or simultaneously, then there will be no loss of prestress due to elastic shortening. If you apply one by one, then there will be loss of prestress. That you should remember. Then shrinkage, creep, relaxation, it is explained as in case of pre-tensioned, same. Friction, you will be come across with 2 parameters, we will discuss it later. Then anchorage slip. And remember, while solving the problems, if it is given calculate the total losses, and he is just mentioned pre-tensioning, the member given is pre-tension member, then you have to calculate these 4 losses. If it is post tension, then you need to calculate these 6 losses. So under which method of pre-tensioning, what are the forces we come across with? If you consider pre-tensioning, elastic shortening, shrinkage, creep and relaxation. If we are calculating for post tension purpose, elastic shortening, shrinkage, creep, relaxation of stress, friction, and the last one is anchorage slip. Based on the question you need to consider, and all these losses are available in the codebook IS 1393. So let us discuss the losses one by one. So first one is loss of prestress due to elastic shortening of concrete. So here when we applied the tensile stresses in the steel or tendon, as I said, the same tensile stresses will develop in turn on the concrete as a compressive stresses, or you can say the compressive stresses are developed in the concrete will be same as that of tensile stresses in the steel. So this corresponding compressive stress in steel, that is the steel try to come back to its original position. So during that time, the compressive stress will acting in the steel. So that will reduce the stress in steel, and that we call it as elastic shortening of concrete. So this is loss due to elastic shortening. So for this we have formula to calculate this. We have formula: strain in steel is equal to strain in concrete. So sigma s equals modular ratio of concrete and steel, that is ratio of modular ratio of steel and concrete, and stress in concrete. Next one is loss due to shrinkage of concrete. So shrinkage, it is defined as reduction in the volume of concrete due to loss of moisture. This you have learnt in concrete. So as the size of the concrete decreases, the stress in the steel reduces. So the reason may be, it may be due to environmental effects, or it may be due to ingredients of the concrete what we have used, whatever, but it is reducing in the volume of the concrete. But it is depend on environmental conditions and materials used. So based on these things, water content, it may be water content, or it may be time of mixture, or it may be placing placing time, or it may be cement content in the concrete, whatever. So based on these things we will have some standard formulas. Sorry, this is IS 1343, not 1393. As per that, we have two direct values for shrinkage strain in the steel. So if we are calculating pre-tensioned members, we will directly consider shrinkage strain as 0.0003, and if we are calculating for post-tension members, it is 0.0002 by log of T2, log of T plus 2 to the base 10. T is age of the concrete at transfer. These T value will be given, but you should be careful whether you are calculating for pre-tension or you are calculating for post-tension, that you should remember. And next one is loss of pre-stress due to creep of concrete. So it is time dependent permanent deformation, we call it as creep. So in creep, estimation of creep losses due to creep, we have two methods. One is ultimate creep strain method and another one is creep coefficient method. The only formulas are different here, but both we will get the loss due to creep. But you should remember which method it is specified in the question. Here is going to specify calculate the loss of creep due to ultimate creep strain method or creep coefficient method, or based on the data you need to decide. See, if you observe the formula for ultimate creep strain method, we have ultimate creep strain into Young's modulus of steel into compressive stress in concrete at the level of steel. It is sigma c. We are calculated in our beginning. And creep coefficient method, creep coefficient, modular ratio, and compressive stress in concrete at the level of steel. So based on the given data, whether it is given ultimate creep strain or is it given creep coefficient, which is the given data, based on that you need to select the formula. If ultimate creep strain is given, then you need to go with ultimate creep strain method only. If creep coefficient is given, creep coefficient method you have to consider. Then loss due to relaxation of stress in steel. The relaxation of stress in steel is defined as decrease in stress with time under constant strain. The example what I have given, for a longer time, if you stretch the elastic, the strain developed in the elastic reduces. So due to relaxation of stress in steel, the pre-stress in the tendon is reduced with time. That is, when you stretch the elastic for longer time, the strain in the elastic goes on reduces. So for example, you have elastic of length 100 mm and you are going to stretch for about 1 day continuously. Then if you leave this, it will not come back to exactly 100 mm. Some 3 to 4 mm will be higher than the actual size. That is, it has lost that strain for 3 to 4 mm. So same thing, similar way in steel also it happens. So for that, what is the loss of prestress it occurred, and it may be depend on the what is the stress you have applied at the beginning stage and what is the temperature. So relaxation due to stress in steel we consider by using this one IS code book. So for that we have table how much relaxation of stress will occur, or in problems it may given in the form of percentage of steel loss of stress is 1% or 0.5%, like that it may give. So that's what here it is given, 0.5, 0.5, 0.7, 0.8. Next one is loss of prestress due to anchorage slip. This happens in case of only post tension member. Here you should remember, after casting the concrete you are going to apply the pre-stressing force. That means there is no proper bonding, or there is no bonding at all between the tendons and concrete. So in that case, after applying the tensile stress, you are going to hold the tendon in the position by using anchorage devices. So one side it will be fixed, and from another side you are going to stretch the tendons. After applying the required pre-stressing force from one side by using jacking devices, you need to fix that tendon with same stress. So for that we are going to use the arrangements called anchorage devices. So after providing anchorage devices, when you release the tendon at the end where you have applied the force, sudden force will occur on the anchorage devices. Because of that force, a small amount of loss of prestress will occur. So that is loss due to anchorage slip. So that is delta, we have formula you can calculate. So this it is available in code book. And the last one is loss of prestress due to friction. The friction generated at the interface of the concrete and steel due to stretching of curved tendon in the post tension member leads to drop in magnitude of prestress along the member from the stretched end or jacking end. See, when we have applied the force, so as I said, there is no bonding between tendon and concrete. By providing grouting, we may give a small amount of bonding over there, or if you provide a curved profile, if it is straight, no issues. But if you are providing curved tendons, obviously the tendon will come in contact with the concrete surface of the duct. So in that case, when you applied the stresses, if you are applying stress of 500 kilonewton at one end, it may not be 100% acting on the tendons because of the friction. Because of friction, out of 500, some 10 kilonewton may require to stretch the tendon. Again it's the friction of the surface, so that thing will happen. So that is loss of 10 kilonewton. As per us, we are applying 500 kilonewton for the tendon, but because of friction, the 10 kilonewton of load is applied for the friction. It is not acting on the tendons. So there is a actual pre-stressing force we are applying is 490 kilonewton. So here, for that we have two parameters. As I said at the beginning, One is loss due to length effect and loss due to curvature effect. So as the length of the member increases, the contact surface between the member, concrete and steel tendon increases. So because of that, as the contact surface increases, the friction increases. It may be, since it is the concrete surface, it may not be smooth. There may be some undulations or some imperfections will be there. So because of all those things, there will be some loss due to length effect. For that we have formula also. These formulas are available in the code book. So when you consider the straight tendon also, even you are providing straight tendon, if the length is more, there will be some amount of sagging will be there. So that sagging is also come in contact with the inner surface of the duct, leads to the friction. So that we call as wobbling effect or wave effect in the tendon. So for that, the coefficient of wave effect will be given in the question. So with respect to that, you need to calculate the loss. And curvature effect, as the radius of the curve increases, you need to maintain the profile of the tendon. So while maintaining the tendon profile, it is difficult to maintain the exact profile. So because of that, there will be some contact in between the tendons and surface of the concrete. Because of that reason, again there will be developing the friction. So because of that, there will be some loss, and these formulas will be available in the code book IS 1343. So this is all about introduction to losses of prestress. From next class onwards, we are going to solve the problems on losses of prestress. We have different conditions, different parameters for different types of questions. We need to solve losses for post tension, losses for pre-tension, total loss. We have different conditions. Later, while solving the problems, we come to know, we can understand the concepts clearly. Thank you.